Hi ladies and gentlemen, good evening and welcome. In this video, good morning to you that's watching, good afternoon to you. In this video I'm going to show you how I fault find. You like that? I've had quite a few requests since I've put the complaints department video up, and people have been coming in with their complaints, and there's no wrong with that, is there, ladies and gents? That's what we call freedom of speech. There's no wrong with that. Some people, for example, I'll run you through some of the complaints. Some people say that when I'm panning my camera around, I'm doing it to show you and show off. You know, like when I go like that there, and basically he says you don't have to make a big deal about showing us that you've got lots of radios. Well, I'll answer that criticism now. Nearly all of the radios, in fact all of the radios that you see in this house, every single one of them have come much cheaper than what they would be if they were working. So I don't spend any more money than most people, I can assure you, you know, that's wrapped up in radio. I really don't. In fact, it's well known round by me that I don't pay a lot for broke down radios. I don't. You know, there is certain things that I have to buy, you know, I just have to have it for the challenge of trying to get it going. But I swear to you, ladies and gents, when I'm panning my camera around, I'm not trying to show off. I am not, honestly. I'm just not that type of person. Criticism number 2 that come from me off the CB, it were regarding the cheap radios. Have you seen that video where I've got a 148 that I paid £10 for, and the Multimode 2 that I paid £10 for? He says you did a good deal with that Cobra 148, didn't you, for a tenner? Well, he's referring to this Cobra 148. Well, you don't get many Cobra 148s for a tenner. In my lifetime, I haven't had many Cobras for a tenner, let me tell you that, right? And it says in the video that this radio needs its prom taking out because it's in a bad way. This is a lad that actually, that's not far away from me. He's in the Bradford area, and so I said to him, I said, it wants a bit of work doing to that. He said, you've only put an audio IC in and a regulator or something. He said, it's only cost you a tenner to repair it. Excuse me, I says to him on the radio, I said, no, there's more involved than that. I said, I've got to take out prom out of it. He said, yeah, likely story. That's what he said to me, likely story. Well, can I just say to you now, pal, I'll do that for you on video, and you'll see the work that's involved at taking a prom out. It's not just simple process, and also it needs another channel selector as well, which I forgot to tell you, and it needs quite a bit of tidying up. And when I put my name on a Cobra and say I've done it, I can assure you I go through it front to back. There's a lot of work in that radio to put it back to what I call a Cobra, let me tell you that. And you will see. The video will shut you up without me saying anything to you. Also, someone says the solder sucker's the wrong way round. Anyway, so here we are today with the President Grant. Has there been any more criticism? I'll try and think of it if there has been any more, right, and I'll bring it to you live and direct as soon as the 2 brain cells work it out. Anyway, here we have a President Grant that's brought down. Another cheapie, and I've already powered it up on the power supply, and I've just seen something, so I'll bring it to you live and direct, okay? So, power supply on. And we can see it's drawing, let's run it to 14. I don't know, 13 and a half, alright. And it's drawing the right current on receive, at 360 milliamp. And it's into a dummy load here, right. And I know that there's no RF being produced. The radio's in FM mode, irrelevant what channel, but it's on channel 19 high band. But it's irrelevant really. And then just watch what happens when I key the mic on the PSU. Can you see power? Look at the right hand meter. Nearly 3 amp. Nearly 3 amp. But it ain't producing any RF. So I'm not going to let it key up for long. So we've got no RF. You see the voltage drop on the left hand side. That's not a fault with the power supply. It's the power supply shutting down because there's some high current being demanded. And something seriously wrong basically. Whoa. It's really an upset little furry little thing, right? That's what amazes me though, seriously, you know, when I mean, do people think that them radios are all easy to repair? Did they really think that, you know, that you just put them on bench and there's no time of head scratching, there's no time of going and swearing and saying some awful words and walking away out of the workshop and saying I'm clueless, I don't know what the hell to do next? There's loads of them days. You just don't get to see them on video, ladies and gents. But and it doesn't matter how much test equipment you've got, you've still got to come up with a plan of action. You know, a plan of action of where to start looking. You know, anyway, let's whip them lids off, okay? I've already got the screws out, so let's whip the lids off. I know that this radio's had some quite heavy conversion. Stand by. Okay, we're back again. To save you the boredom, I've just unsoldered the speaker. Well, actually, I've unsoldered them and then I've cut the ends off. And I always like to have a good look round and assess it first, of just roughly how things are. First thing I noticed that this is the heatsink model Grant, but it only has one final in. And all the components that's required, just hang on a minute, I'll see if I can get you a better picture. All the components that's required to bias the other transistor and feed it with RF have all been stolen. So I've got one 2166 driver, there should be a 1969 there and another 1969 there, but you can see there's only the one final, and like I said, the components are missing there for the others, okay? Also someone's this coil here has been added at some point. It would have normally had one in. It's just working like as a suppressor to get rid of to help to get rid of engine noise and stuff like that, in conjunction with ash transformer here. But you see, all these things I like to put back to standard, you know, that folk don't realise that once it's working there's more work to do, you know. You know, can see it's had quite a bit of conversion going down, right? Look at the PLL. Can you see the PLL, how it sits up on one side? Can you see it? And all this lot going on. Yeah, make you want to rip that completely out, all of it. But we don't do that until we get it working, right? So because I believe that it will probably work with all that lot in situation. So first of all, we're going to see if its receiver's alive, and we're going to use Betty. We're going to ask Betty to produce a frequency and just and we'll run frequency in just to see if its receiver's up and running, even though we know it's got a transmit problem. Okay, stand by. Okay, we're off again. Got the Marconi now running at 27185 at minus 80 dB in FM at 1 kHz tone, and 27185 is channel 19. So that's mid-band, and we're getting an S9 here. Manny, we should do it at minus 80. So receiver's working. That's clarifier moving around, and that's working. I'll put it on another frequency here. RF generator frequency 00 I don't know, 27, I don't know, what should we do, 555, shall we? Okay, it's on 555. So it's working on high band as well. So I think we can safely say that this lot down here is working. That's the someone's conversion sort of carry on there. So what we need to do now is to work out what was causing the massive current demand, right? The argument, as I call it. You know, when something's really creating loads of current demand, basically there's something that's not getting on with each other in there. And, you know, whether it's something to do with carrier regulator down here. Notice that they're different from a 148. This has got a bit of a beefed up regulator to cater for the two finals, and a slightly, nearly identical in design to a 148. It's just that the trannies are beefed up more. Instead of it having a 2SB525C in here, it's got a bigger tranny in, you know, because these two are working as modulators as well for AM, as well as supplying carrier. Right, the first thing that you need to do is say goodbye to Marconi, because we don't need it at this point. What we'll be using at this point is a scope and maybe a counter, maybe, and of course the current meter here, right? Also, sort of criticism. Someone said that my soldering iron went wrong way around, and my cup's handle was the wrong way around. So you'll like that better. Anyway, yeah. So we need to find out where the argument is. Simple at this stage, because you know, first of all, let's rule out the TX strip. By doing that, I'm stopping the collector voltage going to the PA. So now I can key the mic again and see what current I'm demanding. I'm still drawing too much current, but there's much less argument going on. Let's just show you what I mean. You get what I mean? That's the massive. So there's something drawing nearly 3 amp there, but as soon as I remove the bias board, I'm just drawing nearly 1 amp, just over 1 amp, right? So now it's a matter of waking scope up and seeing whether there's any RF coming up here, and we'll also be having a voltmeter in here to have a look, see what sort of DC is around the transistors, right? So stand by. Hi again, ladies and gents. We can clearly see that it's had quite a bit of messing around here in the binary area. But we know that it works on mid-band and high-band. It was easy enough to find out. And even though it's not producing any RF for us counter to operate, rather than even looking at TX mixer, which is here in this case. So we know that 2 bands are working, and that's good enough to proceed. We can see it's had some messing around here with a bit of a poker, and here with a bit of a poker. Regulator stage, final strip, very common for problematic, so they always go in there. So as soon as them 2 bands are working on receive, it allows me to carry on. So I've got my voltmeter up and rolling, and I got me negative supply straight to me power supply. Basically it's just negative to negative at this time. 2 fuses are in there for those that don't know. I'll put my meter like that, you can see it better. Now what I actually want to look at is what's coming out of this regulator, right? And we can see there I've got 7.5 volts. 7.5 volts coming out at regulator, which is really cracking. How can I TX at the same time? Stand by a minute, stand by. It's back again, and voltmeter just start wandering. Now as I say, with the bias board out, I've just coupled this lead up because it's got a TX switch in, and it doesn't allow any audio to go into radio of any description. We're in FM mode anyway, but I can just manually switch it to transmit. I wouldn't normally do that, it's just that with camera, holding camera at the same time. We know that there's roughly, excuse me while I just refocus camera, do I need to do that? I can just come back a bit here, that's better, isn't it? We know that roughly regulators producing about 7.5 to 8 volts, 7.5 in this case, which is good enough for AM and FM for collector supply, which will be coming at the source pin, that's this one here. These two pins, that one drives the collector for the two trannies, which is only one in this case, but that would drive the collector for the two, and this one would drive the collector for the driver. So I don't want to keep it in TX for too long because it's still drawing far too much current, even just at 1 amp. Right, it's still too much current, so I'm going to be brief, and what I'm going to be looking at is here, and just see how much source supply I've got on here. The two transistors at the back end can't be in the argument if the bias board's out, because there's no collector supply to them. So first of all, I'm just going to TX, and I've got my 7.5 there, right? That's all I want to see at this stage. So there's something that's pulling that rail, well, it don't have to be this rail, but there's something pulling quite a lot of current out in the TX strip. It could be something to do with this, but first of all, we'll get a scope going now, right, and we'll see whether there's any RF coming from this area here. This is a TX mixer, and first of all I'll show you how it works. I'll show you roughly how the TX mixer works, okay? Stand by. Right, ladies and gentlemen, I can't show you how the TX mixer works because the TX mixer is not working. No, I can't show you how it works. So in other words, we're going to have to find out what the problems are first, right? I don't blame the TX mixer. I believe that I've just had a little look with the voltmeter here, and I can see some major problems in the TX area here when it comes to the state of DC. Just bear in mind that for an output stage to work, the state of DC that's driving them trannies must be correct. If there's something that's amiss, it just won't work. It just simply won't work. A bit like a light switch, you know, if all the connections are there to the light, or one of them's missing, it just won't work. It's the same carry on with an RF amplifier. You know, it just has to be, the amplifier has to be switched on and ready for operation. Just forget this ground loop here. Right, so I'm going to have to refocus the camera or something here. Can I do it through that? You can see it a little bit better, can't you, but not much. Anyway, for those of you that's looking, you know that there's 3 connections on driver, 3 connections on final. You can see them 3 that they're not being used here, and 3 connections on other final in this case, and they're laid out in this manner: base, collector, emitter. Emitter goes to ground, so you've only 2 connections to worry about. Don't even have to worry about this tranny at all because it's not even present. And same again, base, collector and emitter. Now then, there is another pin that's here that's just at this side. Can you see that? Well, this is your bias thyristor, or known as the MV1Y, but basically it's the bias junction actually works across that, as well as it being a thermal compensation diode monitoring the transistor itself, but it's also coupled up to base circuit. So if the the transistor's getting too hot, this can actually lower the bias across the tranny, and that's why it's coupled up here, and the other connections to deck, ground in other words. And exactly the same applies on final here. This little pin here, I don't know whether you can see it, but this pin here is one side at diode and other one goes to ground, firmly connected directly in front of the transistor, right? So if I switch the radio to TX again, This isn't easy to do, you know, because I don't want to have it TXing for long. So you can get me thing a little bit closer there. I put it in TX and I immediately look at the base junction, and I can see there I'm reading 1.2 volts. Well, 1.2, there won't be any collector supply. There won't be any collector supply because I've got this out. Right, now there should be 0.7 of a volt. There should be 0.7 of a volt on the base of that tranny. Right, and there is no voltage at all on these back finals in any way. Once that's gone out, there should be nothing apart from 0.7 possibly coming to base of each junction of each final. And also when I look to see RF coming out of the TX mixer, I don't see any RF coming out of the TX mixer. In fact, the TX mixer is really quite upset, or giving us the impression it's upset. But I think we need to refer to paperwork at this stage, right? So let's get some paperwork on the animal, and we'll carry on. Stand by. Okay, I'm back again, lads. When I try and run camera through that through this here, it really don't like it. You start seeing it blinking and all sorts. Anyway, this is the President Grant manual here, and we're interested in this area here. I'll give you, this is the TX mixer. This is this area here, right? And just show you basically what happens. There's two signals. A mixer does exactly what it says it does. It mixes signals together basically to produce a new signal. In this case, with some slight amplification as well. One signal comes in at this point here, through that resistor, and on this transformer here, or coil, whatever you want to call it, and the other one comes in at this point here. Right, so one signal goes in, two signals goes in, and the output comes out of this here, these three connections, center tapped, and comes to this, and it's this transformer then that goes through this coil and then into these transistors here, and this is the TX strip, known as the TX strip. There's your two final transistors, two 1969s. This is the 2166 driver. This is the pre-driver buffer. So you, like I say, the RF should be the final 27 meg RF, because they're not. One of them will be 10240 megs, and the other one will be the VCO. I think they run at 16 megs. I can't remember, but we'll see once we get it working. I'll show you how it works. So the two signals come in, like I say. Then this is the actual part, you see, where the lock detector robs the TX strip of supply if someone's trying to give it an illegal frequency. This is your PLL, and the PLL chip here has an active supply that's about 8 volts driving this chip. Well, if there's any illegal frequency of any description, this chip will just get robbed of its supply and its 8 volt TX rail, so the TX strip won't transmit, you see. That's not the problem in this case, I'm just saying that. But so once it gets its TX switch on supply, when you keep mic, the transmitter TX RX switching supplies this lot up with supply and puts the RF at the two separate points at the same time. Then RF comes out of here, like I say. Everything's capacitively coupled, right? So you know, because the last thing you want is voltage jumping from one side to the next side to the next to the next. So from the RF, as it comes out of here, it goes through this capacitor, so no DC from here or here is into circuit, right? So we've got RF, this is an RF signal passing, and from that point on, because that capacitor's there, whatever DC's in this area here never gets passed, right? Then it goes to this coil here, and then there's another capacitor there, So the RF literally can just continue on, but no DC can, right? And then it goes into the base of this tranny, collector, emitter and base. It goes into the base of this tranny, and as you can see, it's tied to deck, tied to ground. So then RF then passes onto the next stage. That one stage is just a buffer, and that capacitor there is the connection, is the RF connection between this tranny and the next. So because there'll be supply on here, let me just get a pointer. There'll be some supply voltage on here, right at this point here. This is collector, and RF will pass to that, and then literally pass straight across through this capacitor. There will be, I don't know, 8 volts or something on there. There'll be 8 volts. So the voltage then gets blocked, if you like, by this cap. RF then passes, goes into the base, which is the input of the next tranny, right? And then RF comes out at collector again, right, and goes to this capacitor here. Can you see him? From that point there'll be 8 volts again on there, but the DC cannot pass. It just can't pass. It gets its DC by here, look, coming up this coil to drive the tranny, and the DC will come from the same point as this one gets this supply. Do you get what I mean? Can you see that? That'll be the 8 volt TX switch rail. So it gets its DC coming up here, right? And once RF gets supplied, i.e. RF coming into base and RF being amplified and then coming out at collector, only the RF can pass because there's a capacitor there. So no DC passes again. Then we go into the base junction. So RF passes out of this cap, goes on to the input of the base here, and the supply of this rail is different. Instead of it getting it from that 8 volt switching supply, this tranny and these two trannies get it from they get it from here, right? Because they need to be regulated to right supply, which is done by regulator, right? So and we can probably see that by here, by there, look. If you look here, this is source coming in from regulator. This is the pin that drives the base driver state, and this is the pin that drives the collectors of the 2 finals, right? It's the same source that drives the 2 finals and the same source that drives the driver, but these, of course, all this lot from here has its own 8 volt supply because they're all low current. Now then, so basically I've now got to find out why there is such a high voltage on the base. Sorry about that, ladies and gentlemen. My camera run out of space. There's only a 2 gig memory card in this camera, and I've turned the light off on this so that obviously we don't get the blinking, and I'm hoping that you can see enough of it, but I don't know whether you can. I don't think you can. See if I can get some more light in that area. Yeah, it's not good, but anyway, we'll try and proceed where we left off. I made a mistake, by the way, when I said earlier on that we might see the base junction supply here, i.e. 0.7 of a volt. You won't. Once he's out, you won't. You might see some RF coming to that point. In fact, you will, but you will not see no voltages, because you just won't, because of everything being capacitively coupled. Right, so I brought you out of the TX mixer area here, through this transformer, through this capacitor. Remember, no DC passes from here to here because of this capacitor, right? RF passes only, goes into this coil, RF passes only, and gets to buffer here, which let me just tell you also that the supply rail that the TX mixer uses, i.e. roughly 8 volts, right, is the same supply as what this tranny and this tranny work on. and it's only because they're low current, as I say, and these guys here, the driver and the two finals, are high current, so they get driven from the regulator, and at the same point that's where AM audio gets put in. AM audio gets put in here from the regulator state, from the regulator supply. There's no point in telling these guys here to produce amplitude modulation. They're just working as RF amplifiers, a buffer amplifier, etc., until it gets to this point here, and it's an AM modulation gets added at this point on these, just on these lot here, right? Now it's important what I was saying regarding the DC coming up this rail here, the DC supply coming up here. So just bear in mind, this is the transistor, right? This is the transistor here, the driver, where we see in we should see 0.7 of a volt, but we're not. We're seeing 1.2 volts. So this is the issue. But the reason I'm not seeing any when I scope the output of this TX mixer here, I should theoretically see some RF right here, 27 meg RF, after the sum and difference is going on. In other words, after the VCO frequency and after the 10240, the two signals get mixed, amplified slightly, and then I should see the 27 meg here at this point, and here, and here, and here. But I don't see any of that TX 27 meg, right? Now, the reason why is because, I believe anyway, like I said earlier, we've got we should have 0.7 of a volt here, but when I pull the bias board out, right, when I pull the bias board out, I've still got 1.2 volt. Wow, did you hear that then? That were a bang outside. It's just neighbourhood shooting each other, it's no. Anyway, I should see 0.7 of a volt here, only when the bias board is in. But I still see 1.2 volts here, and the bias board isn't in, proving to me that there's something wrong with something here, either here or here. Now, it can't theoretically be here because the bias board is out, right? But this would naturally get 8 volt TX supply here coming up this rail, and this would also, like I said earlier, get 8 volts to collector coming up this rail. Notice it's same point. Can you see it? Can you see that? Right, so that'll be the rail, that is the TX switch rail. Right, now then, the reason why I think the TX mixer isn't working is because for me to see any voltage there at that point, right, what I need to look at now is how much supply there is here on the collector of that tranny there, transistor 44. I need to see that I've got my TX supply rail. I don't even have to go to that tranny. In fact, because TX mixer's unoperational, it'd be nice to look at this point here, this whole rail here, and just see, because if that rail sits at the same supply as that what's at this point here, then we've got a short going on. Okay, stand by. Tell you what, you guys like this camera because you like the picture quality of it better, but it is terrible to make videos with. It really is, because of the fact that I can't focus while I'm working. It really is terrible. It's a nightmare, to be honest, and focus is rubbish on it. I'd love to get you much closer than what I am now, but I can't do. Right, so this is the TX strip area here, right here. This IC represents this chip here, and basically what I'm looking at now is this rail. Now I can tell you there should be about 8 volts on that rail, and 8 volts drives this TX mixer, it drives this tranny, and it drives that tranny and this TX mixer, right? And it gets 8 volts only when I key the mic, right? Now then, this is the rail, this rail that you see here, it's in, right, where it gets its 8 volts from. Now again, it's going to be tricky. I'm going to have to put it into TX. So I want to see 8 volts there, right? Animals in TX, trying to be quick. Now that's millivolts. I'm not even on it. Oh, it's smoking. Oh, sorry about that, folks. It's been smoking. It's been smoking. Very rarely happens in my workshop where I see smoke. I did not smell smoke. Sorry, I did not see smoke. I smelt it, and then I heard the receiver disappear. Yes, it's true. Now then, what's been happening? Why has it started smoking? Well, I've lost my receiver. What were happening, right, is we were looking at this rail. This is the 8 volt TX rail that basically supplies the TX mixer and basically the supply for the buffer and the pre-driver all gets run off this TX 8 volt rail, right? But the reason why the TX mixer is not producing any RF is because there is no 8 volts TX. There was before it broke down 8.2 volts on the supply of this TX mixer and the pre-driver and the buffer. There should be 8-ish, but there were only 1.2 volts. 1.2 volts, just remember the 1.2, because it's the 1.2 that I see exactly at the base of the driver transistor. There's a clue, ladies and gents, there's a clue. Now then, so when I turn the animal on now into receive, we can see that I'm now, even though I've got no receive, full volume, no receive whatsoever, but you can see I'm drawing much more current now. It were about 350 in receive, and now you can see about 530. Turn it back off again. Right, multimeter on, and now then, this rail here, let me just see if I can get a bit closer. Stand by. Oh, I might be able to just do it here. I can, yeah. Anyway, this rail here, this rail, the one right down at this side here, right, this rail, he is the one that supplies, if you like, all of that. The TX mixer, he supplies the buffer and the pre-driver, right? But he should be about 8 volts TX only, and nothing in receive. But if you look now when I turn it on, I've got 6.7 volts in receive. In receive. There should be nothing there in receive. Anyway, let's refer to the manual and we'll see what's going on there, okay? Okay, so here we are again. Now then, like I say, on this rail here, there should be about 8 volts TX only, absolutely zero when it's in receive, and you can see we've got some voltage. Now that voltage, whatever's happened, I'll tell you what'll have happened. Because of the high current demand at the beginning of all this, it's been putting stresses and strain onto probably the supply rails, and you know, like I say, you know, when you see it drawing, say, 3 amp like that right at the beginning when it's in TX and it's not producing any RF, I reckon all of this rail here, all of this TX 8 volt rail has been under some serious stress, right? And now we see, while I was looking for that voltage, I noticed that this rail here, the first time I touched me probe on it, it was about 1.2 volts, exactly the same as what I saw on base at driver, and then all of a sudden it just started rapidly going up to about 6 volts, what we see there today. And so all we've got to do is find out why that is there in receive now. I did smell a funny smell, and all of that lot comes from the TX RX switching arrangement, which is here, transistor 37 and 36, and the one in the middle is the TX switch. Basically the two end ones here are source regulators. In other words, when this transistor turns into different states, in one occasion it turns this one on, and this one allows 8.2 volts to go to receiver, let's just say. It could be transmitter, but whichever way around. One of them supplies 8.2 to receiver, and the other one toddles off to 0. And when it turns other way, he supplies 8.2 volts to transmitter, for example, and the other one toddles off to 0, turning loads of different circuits in the receiver and transmitter on and off, or should I say supplying loads of different circuits or not supplying. Now then, so chances are, because we've got 6-7 volts or whatever on this rail, chances are what's giving up the ghost is one of these transistors. And all we've got to do is meter the collected outputs of these two trannies here, and we should see about 8 volts in TX state, and it should go to 0 when I let go at mic, and then the other one should go 8 volts and go to 0 when I let go of the mic, vice versa. So let's just do that right now. Right, it's back again. Right, radio's in the off state, because you can see that it's under strain when it's doing about 500 or 600. There's something getting upset for whatever reason, so I'll turn it on and try and get this test done quick. Radio is on, believe it or not, and I'll just meter the collectors of one of these trannies, and it's in. He's 6.7. He's roughly what I see down here at the back end. Oh no, it's a bit higher there, isn't it? Anyway, where's the other one there? Right, so he's 8 volts. Right, he's 8 volts. Switch it to TX. It's in TX now. Same point again where I got my 8 volts from. And he's at millivolts. That means he's gone back to 0. Right, so one of them's turned on and off. Right, and when I go to other one now, he should be 8 volts. But he is only 7 point something. And when I switch it to TX, oh, look at that, he's now 7.9. so there's a tranny here with an issue. Let's just put him out of his misery and turn him off. There's a tranny there that's got an issue, right? I don't know which one, but so the one that's giving the funny readings, I think it's him. We'll pull him out, and we'll give him a test. Okay. In fact, I believe that the reason why the receiver's dead now is because there is supply on this rail in receiver state. There should be no supply on here at all in receiver. And chances are some of the trannies that's switching, you know, the receive and transmit, some of the trannies that's being supplied by the TX-RX switching is, in other words, driving circuits that shouldn't be driven at this time, if you know what I mean. Because there's still supply there. Well, if there's still supply there, there'll still be supply to loads of other different parts at radio. So we're just going to pull the affected tranny out that we believe is faulty, and by doing that we will see it in a different light. Stand by. Okay, ladies and gentlemen, so I've taken the tranny out here. and now we have receiver again. And if I look on this rail, looking at the current demand now, we're back to normal, 350. And if I look at this rail in receiver mode, it should be nothing, virtually millivolts. That's excellent. 17.6 millivolt. That'd be near, more or less ground potentially. If I touch ground there, I'm just on a ground, and we can see 17.9 there. So basically this is absolute zero now, right, as it should be in receive mode. Right, so this was the culprit. When I test it, it's shorted. It's shorted on its base and its collector. It's a 2SB525C, and it's basically a source regulator. You know, it's a source regulator. He gets his supply, by the way. If you want to know where he gets his supply from, he gets it from 473. He gets it from here. That's the regulator that's on the side here. This is the main 8-volt regulator. 12, you know, full supply goes in 13.8 or whatever, and then 8 comes out, and that source, if you like, drives the two source regulators. One of them drives the receiver and one of them drives the transmitter. So in other words, because of all the argument that's been going on in this TX strip here, including me with the camera TXing it for too long as well, right, because it'd be much quicker repairing this radio if it you know, if I want holding camera, you know, I wouldn't have it TXing for as long. But anyway, so now what we'll do is we'll have to fit another transistor in, another 2SB525C, and then I won't have to have it TXing again for you. And what I'm going to do then is find out what's going on then in this area here. Okay, stand by again. Okay, ladies and gentlemen, we've had a little bit of fun with this radio while you've been away. You don't notice that you've been away, you're just continuously there, aren't you? But extension speaker turned out to be very, very intermittent, so I've had to wire in a loudspeaker here, and that's because the extension speaker socket itself is it's got some issue with it, and the only way to replace it is well, basically you've got to take all this lot off here, all this lot, and this regulator here, and lift the board up, unscrew the board clamps that's holding board in, and believe it or not, lift the board out. I've tried to get it out, but you just can't. Some models you can, some models you can't. I've tried cleaning it and all sorts, but it's just grossly intermittent. Anyway, we'll tackle that another day. Anyway, a new transistor's in now. 2SB525C had gone to another planet on both of its junctions. So now we've got 8-volt supply in TX and 8-volt supply in RX, as it should be. Multimeter on, and now when I look at its RX supply current, it's 3,500, which is good. And when I switch it to TX, it's 540ish, 530ish, which is really excellent, right? Now then, what I've done, I've stopped this argument that's been going on here, because I don't want to blow another tranny, and I've just lifted the bias diode up. You know, the bias diode that connects across the driver tranny. Well, I've just lifted that up, because what I believe is happening is it's not the bias diode that's the problem. Bias diode checks out okay, but because there's still some supply voltage on that base here, either tranny's turning on or something like that and shunting some current to ground, something like that. But just by disconnecting the bias diode for now, I've stopped the argument. That's why when I TX, I'm hardly drawing any current again. Right, I should be drawing more than receive, because more higher current circuits are coming into play now in TX. Right, now, so if I look at that rail again now, I did see before it broke down the exact same voltage as what I saw at the base here. I saw 1.2 volts. I should see absolutely nothing in receive, and I mean nothing. Okay, so I'm on that rail now. That's the TX 8 volt supply, and I'm 25 millivolt, which is what we call nothing. Right, that's lovely. Now when I TX, it should go to about just under 8 volts or something like that. Okay, 7.8, well 7.9, which is lovely. Right, now then, because of that there, that should allow me now, this TX mixer now I know is getting some supply, and so will the buffer, and so will the pre-driver, so we should have some RF coming out of it. Right, so scope yonder, and we'll just give it an earth clamp, and we'll have a look, see if we've got any TX being made on the output of the, oh, you can't TX at the same time. So I put radio into TX, and then we'll look at where we'll look directly at the base, and we can see there that's no probe on, and we can see RF is being produced, right, directly at the base, but we still haven't sorted out the argument which is making it pull massive amounts of current and raisins. Right, so what I'm going to do now is I'm going to bring in my voltmeter. Let's just have a look at the frequency of that. You wouldn't normally use a probe, by the way, to look at frequency on your counter, but we can do in this case. We can cheat. I put the radio in TX again, and we can see their counter saying 27105, 27105, channel 12 mid-band. That's right. Right, so so now what we're going to do now is suss out why the argument is there. Right, so if we switch it to TX now and look at this base, here, you can see 0.79, right, but if I go to this point here, can you see I've got there, I'm just on here, right, basically this connects directly now to the collector of this tranny. Let me show you the tranny on the paperwork. Right, right, basically, ladies and gentlemen, my meter probe now is here, right at this point, and there should be this is the TX rail that we're on about, the 8 volt, just under in our case, and it goes up here, right, and we've looked at all this. We can see outright supply on here, and here when I get to this point here, we're going to find out, you see, why there's some voltage at the base. So so if I go there, which is where I'm putting my meter now, I put it into TX, and I can see there, that's the 8 volt supply. That is in reality there. That's there, right? So all I've got to do now is to find out where the DC is getting from here across to Fred, and we'll need to look at that capacitor there. So if I go from one side of the capacitor, which is there, 7.8 or whatever, 0.7. Yeah, I reckon it's that capacitor, me. I reckon it's that capacitor there where the supply is jumping across. Let's put it out of TX and let's whip that capacitor out of there. Okay, stand by. Wow, what a drawn out video this is. I hope you're still with me, ladies and gents. Right, my meter's in resistance mode here, and this is the capacitor in question. And when I very difficult to do with camera. Stand by. We can see it's reading there, look, like 500 ohm, 0.480 kilo ohm, which is 500 ohm. Now there should be no resistance, so he's out of there. He's definitely out of there. And according to him, according to paperwork, I think he's a 330 picofarad. Let's just have a look what it says it is. I can't see it with that. Yeah, 330 picofarad, right? That's what it should be, 330 picofarad. Now what I'm going to do is I'm just going to have a look at the RF coming out of it now. I'll plug it back up and I'll have a look at the RF coming out. Well, I might as well just find a capacitor and put a capacitor in. Stand by. Sometimes the electrical gods are with us. Right, so that's the capacitor that's got some great resistance in him. And now if I switch it to TX and I get my probe and I look at the base where I saw the supply before, you can see now minus, you know, 0.3. That's excellent. I'm happy with that. And we'll have a look at the RF at that point. Oh, loads of RF now. Right, loads of RF. So now what we'll do is we'll put the bias board back in now and allow the collectors to have some titty on them trannies. Okay, stand by. Okay, we're back again, except this time we're into a dummy load now. Got his bias board back in, and if we TX, let's just get a better look at that. We can't see it. If I TX now, got 5 watts on the table. 5 watts of RF. Now then, what does the base junction sit at now? Okay, should be 0.7. About 0.7 or anything like that will do me nice. Yeah, look at that, 0.716. I'm happy with that. You're happy with that, aren't you, ladies and gents? Right, so let's go and I'll go into other room now and swap its aerials over, and we'll see if we can talk to someone. Okay, so we're into an antenna now, President microphone. Got my mate Brian on here already. Hello, Brian.
Yeah,
The viewers would like to hear you. How can you hear me on a standard microphone, by the way?
Oh, very well.
Are you being serious, or are you just saying that because you know I'm filming?
No, because you're filming from Mark. You're coming through very, very well, as you always do.
You're just saying that to make me happy. And I haven't even paid you £5.
Hey, well, if you're talking about money, well, you're super.
Shut up!
Hey, shut up there. Well, hello, Mr. Van Gaal, Mr. Marley. You know, get a fiver, Mark, and I'll say what you want me to say.
Yeah, I used to say it's bestest signal you've ever heard in your life, and I'll be down in car.
Hey, I never get anybody any stronger than you anyway, Mark, so, you know.
You won't get no money out of me, even for the Radio 2 or the Radio 29. Anyway, Brian, I have to go because There's a bit more to explain on this video, right? It's President Grant I'm working on, Bri.
Yeah, I was bloody working on something you were like, this radio now, Mark, is alright. You know, keep keen up on it, needle goes down and it might work alright, like, but Mark, you know, I'm going to let baby come off anyway. I'm sure you're going to be able to put a new signal meter in it for me, please, mate.
£580, pal. I mean, I know you've just given me a good radio check, but if you want me to put a signal meter in a Superstar 3900, it's £648 plus VAT.
Better.
Pardon?
You're a nasty jet, you are. Call yourself a man.
I'm one of your bestest.
What am I bestest? Fucking hell.
Oi!
Gonna fucking come up next.
Hey, swearing like mad. You're swearing, Brian. I've got to go. Can't tolerate swearing on video. You're going worldwide. Catch you later, Brian. Wave goodbye.
You'll be happy you didn't tell me that, sir. I apologise, everybody. Bye-bye.
Okay, listen, ladies and gents, let me just go back to channel 12 here. Channel 12, right? Now, what's the frequency of channel 12? What's the frequency of channel 12? Let's put me probe there. And my probe there. Sorry for him swearing, by the way, ladies and gents. I can't help that. Oh, I'm gonna have to plug. Oops, I'm gonna have to plug this PTT switch back in because I can't drive it all with one hand, and I need something to keep mic for me continuously, right? So if I just get it to keep mic, oh, we can see it there. Look, 27185, right? That's channel 12. Now then, how does it work? I said to you earlier on that I'd explain roughly how the TX mixer works, right? And I made a mistake earlier on, by the way. I told you that 10240 megahertz comes to the TX mixer. I must have been thinking it receiver. It doesn't. It doesn't. What we've got is VCO signal and the carrier oscillator. And it's them two signals that produce the final, in this case 2718105, right? Now then, I don't know which one it is, whether it's this coil or this one, but coming down that line, there's either a 16, to produce that final that you see there, right, there's either a 16.410, either there or coming down here, 16.410 megahertz coming from VCO, 16.4710 and a 10695, right? How can I prove that to them? I get a calculator here, exhibit F. I turn the calculator on and I go 16 point, what is it now, 410, 16410 add 10.695, 27105, right? And that's all the TX mixer does. That's all it does. It's sum and difference, basically. Sees them two signals coming into it and it adds them together and produces a new signal, i.e. from the 16410 and the 10695. Remember, the 10695, whichever one it is, it's only there in TX, and then from there it makes its new 27 meg signal, comes on here and then comes out, as I say. That's the capacitor there that was shorted, and it were him that were allowing the some voltage to come from the collector here straight onto the base of the next tranny, and that short there were killing the old TX strip because it were pulling the rail down. That's why it wouldn't TX, because it were pulling all this rail right down low, robbing that of supply, robbing this buffer, this, you know, pre-driver or whatever here, robbing them all of supply. So they go low, these guys get no to amplify, hence no RF, no talking to no one. Anyway, I've had enough of messing around here in workshop for one day, so I'm going to go and turn all this lot off now, right, and I'm going to have a cup of chow. There's no way you can stop me, no way you can stop me, and we'll have a cup of tea, and then at some point later on I'll have to do something about this extension speaker socket here. Can't tolerate it like that. Then I don't know what we're going to do, tidy it all up or whatever. I don't know. Anyway, yeah, at least it's working again.